Hello friends, welcome to the first lecture. This is a platform from where I would like to educate physics to class 12 students. So without wasting much of the time, let's understand class 12 physics. Okay? So I write here class 12. In particular, I'll be teaching you physics. So before I get into this class 12 physics, let me first understand what physics is. Physics is basically, it is a branch of science. It is a branch of science that deals with that deals with the measurements of physical quantities Okay, so this is the definition which you must have learned in class 11, and you all must have studied in detail physical quantities like fundamental physical quantities, derived physical quantities, 7 fundamental quantities were there. So all these things we must have read. Okay, so once you have understood physics, now let's see what all topics are there in class 12 physics. Okay, so basically this class 12 physics can be classified into 3 different categories. Okay, so the first one will be called as your electromagnetism. Next one is optics, and the third one is modern physics. So this is your broader classification or the topics what you are going to cover in a broader sense in class 12. Okay, so let us be very specific. So to be very specific, let us first see how can we divide this electromagnetism. Again, this electromagnetism can be divided into 3 parts. Okay, so let me divide it. First part, we call it as electrostatics. Okay, now what are we going to study here? As the name suggests, static means it is at rest. Electro means electron or the charges. So basically in electrostatics you are going to read about charges that are at rest. Okay, so this is the first one. Then the second one which you are going to study is your magnetism. So what happens here? Here the charges will move with constant velocity. Here the charges will move with constant velocity. Okay. The third category what we are going to study will be your electromagnetic waves. It will be your electromagnetic waves. And what happens here? Here the charges are accelerated. Okay, so these are the 3 broader classifications on your electromagnetism, right? Now what all chapters are there which we are going to study in class 12 physics? Okay, so once we consider this electrostatics, the first chapter in electrostatics which we are going to study is your electric field and charges. Okay, the second chapter which we are going to study in electrostatics category, that will be your electric potential and capacitors. Okay, so these are the first 2 chapters which comes under electrostatics. That means here the charges will be at rest. Okay, now when the charges move with constant velocity, they produce one different phenomena, that is magnetism, and also when charges move we know that it gives rise to current. So the first topic which we are going to study in this magnetism category, that will be your third chapter in class 12, that is your current. Okay, then the fourth chapter is your magnetic effect of moving charges. Okay, then chapter number 5 will be your magnetism and matter. magnetism and matter. Okay. The sixth category will be your electromagnetic induction. We will read in detail about this. Just I want to give you a brief idea what all topics we are going to study in class 12 physics. Then the seventh one is your alternating current. So these are the five topics which you are going to study where the charges will be moving with some constant velocity. And the eighth chapter where the charges are being accelerated, you'll read about electromagnetic waves. Electromagnetic waves. Okay, so this is your broader classification of electromagnetism. Now what all classification, what all chapters, sub chapters are there in optics? Let's see. When we come to optics, we have two basic chapters here in optics. That is that will be your ninth chapter of class 12, that is your ray optics, which you have also some part of it you have studied, your lenses and mirrors, which you have already studied in class 10. And then the chapter 10 will be totally new for you, that is your wave optics. So these are the two chapters which you are going to study under the category optics chapter. Okay, then coming to your modern physics, you have got nearly 4 chapters which you have to study. Okay, the first chapter of modern physics and the 11th chapter of class 12 is your dual nature of light. So in this chapter you will know that light has dual nature. At times it behaves like a particle, at times it behaves like a wave. Okay, so dual nature of light. Then chapter number 12 is your atom, and 13 is your nuclei. Okay, and the 14th chapter, of the last chapter of class 12, will be semiconductors. So now you can ask, sir, why did you give all these things in the first class itself? Because I just wanted that you should know what all things you have to cover in order to achieve good marks in class 12 physics. So these all things, this flowchart should be in your mind, which will make your path very simpler and you can achieve your goal properly. So without wasting much of the time, let's go and study the first chapter of class 12 physics, which is your electric field and charges. Okay, so let us go to the first chapter of this, which is your electric charges and fields. So first we have to study about charges. In this chapter, the first concept we should know is that of charges. Okay, so charges are nothing the way. So first I would like to say, the way we had every material particle was associated with a property called mass. Similarly, every material particle is also associated with additional property that is called electric charge. So any material particle you have, any material particle you have, you will have two properties. One is your mass, the other one is your electric charge. Okay, so these are the two properties. Okay, now basically you can also call them to be your inherent property of a particle. You can call these two as inherent property of a particle. Okay, now the question comes, is there any proper definition to the charges? So I would suggest that the best definition which suits is your, I can quote and say, charge is best understood by what it does and not by what it is. Okay, so this would be a better way to explain what charges are. So now the next thing what we should study is the properties of charge. So let's give a heading. It's a properties of charges. Okay, So the first property which comes to the properties of charges, the first property is it is a scalar quantity. It is a scalar quantity. Okay. So although the second property will be the unit, and the unit of charge is Coulomb. All of you know the name of the scientist Coulomb, and you also must have read the in class 10th Coulomb's law. Again, we'll read in today's class also Coulomb's law. So the unit is Coulomb. And what about the dimension of charge? If we talk about the dimension of charge, the dimension is going to be AT. Okay, then the fourth property is there are basically two types of charges, and they are positive and negative. There are basically two types of charges. And the fifth property is a well known property by all of you, that is like charges repel, and unlike charges attract. So can anyone guess who has found this experimentally? Yes, if you have guessed Cavendish, then it is the right one. It is Cavendish who has discovered this. This is the name of the scientist. Then the sixth property is, remember, the smallest charge for us is going to be your electron. Now you can ask here, sir, we have read about quarks, what about them? For the time being, forget about quarks and understand the smallest charge is your electron. Then what is the charge of electron? These all things you have to remember. Charge of electron is 1.6 into 10 to the power minus 19 coulomb. And what about the mass of the electron? Mass of the electron will be 9.1 into 10 to the power minus 31 kg. Okay, then another important properties which are there, the seventh one, this is very important, which is called additivity of charges. This is your additivity of charges. Okay, now in a material, suppose you have got charge of plus 1 coulomb, you have got plus 2 coulomb, and you have got minus 1 coulomb, you have got minus 4 coulomb, then plus 5 coulomb suppose you have, then what will be the total charge on the body? The total charge will be plus 1 plus 2 minus 1 minus 4 plus 5. Okay, so this positive and negative signs, they are important, you cannot miss them. Okay, so basically you have plus 1 plus 2 minus 1 plus minus 4 plus 2, so plus 1 minus 1 they get cancelled out, plus 2 minus 2 you have, plus 5 minus 2 is plus 3 coulomb. So this is how you can find out. So it is additive property of the charges. Then the eighth one is your quantization of charges. The eighth one will be your quantization of charge. So in order to understand this quantization of charge, suppose in today's date I will ask you, give me a 10 paisa coin. Maximum of you will not be able to give it because the minimum one is 1 rupee. Okay, similarly, suppose you are given with a neutral body. This is a neutral body, and what we have, what we have here, we have the number of electrons will be equal to number of protons. Right now, if I'll ask you that from this body give me 1.73 electrons, can you be able to give me? No. If I ask you give me 2.17 electrons, then also you cannot give me. Either you can give me 1 electron, or you can give me 2 electron, or you can give me 3 electron. Okay, so basically we can define this as the amount of charge given to an object can have only certain values which are integral multiples of a certain minimum. Okay, this can be written as total charge in the body will be equal to plus or minus Ne, where E is your electron. And what about N? N is a integer and it can have value 1, 2, 3 likewise. So this is your quantization of charge. Okay, now next property is charge is conserved. Charge is conserved. Okay, so for that let me demonstrate. Suppose I have an isolated system. And in this isolated system I have got two bodies. Okay, now in one of the body I have 2 Coulomb charge, the other body I have minus 1 Coulomb charge. Now something I did with this isolated system, some changes I did with this isolated system, and I observed in the two bodies, first in the one of the bodies the charges was 5 Coulomb. Now the question is, how much Coulomb will this body possess? So how can you calculate? So here 2 minus 1, that is plus 1 Coulomb. The total is plus 1 Coulomb. Now here is 5 Coulomb. Then what should be here? How much should be the charge here so that the net will come as 1 Coulomb? So I have to keep minus 4 Coulomb here. It should be minus 4. If it will be minus 4, then I'll get plus 1. So that means charge can neither be created nor be destroyed for an isolated system. Or to be very specific, we can say for an isolated system, initial total charge is equal to final total charge. Okay. So let us go to the last property of charges, which is very important. For that you need to understand that mass sometimes it depends on the velocity by the formula m is equal to m naught 1 by root over of 1 minus v square by c square. Usually we don't use this formula. Why? Because we see around bodies which are your car which is moving with a speed of 100 km per hour. So those velocities were quite less in comparison to the velocity of light. C is velocity of light. So since v velocity is very less, then v square by c square, 1 minus v square by c square will be equal to 1. Then what happens? M is equal to m naught. What is m naught? M naught is your rest mass of the electron. Okay, so this is basically m is equal to m naught. That is why in general we don't speak of this. But if we can move the mass with a very high velocity, then what we'll observe, mass will vary with velocity. Since mass and charges are integral properties, or they are related to a particular body, therefore we can say here mass depends on velocity, whereas charge is independent of velocity. So these are the 10 properties of charges which is very important for you and you should keep in your mind. Okay, so if you have gone through the video up to this much, then I request you kindly subscribe my channel, which would motivate me to bring some more interesting and new topics to you which are related to class 12 physics. I will continue giving such kind of lecture videos from chapter 1 till chapter 14. So kindly subscribe it. Okay, now let's go to a new topic, that is your Coulomb's law. We'll go to the new topic, that is Coulomb's law. So all of you know what Coulomb's law is. Suppose I have a charge Q1, I have another charge Q2. Okay, then both of them are positive. Then what would be the force? It is quite obvious. Force on Q1 will be in this direction, which is F12, and force on Q2 will be in which direction? Repulsion will be there, both of them are positive, that is F21. Now who is going to repel Q2? The first charge, Q1 charge. So basically your F12 is the force. Since the charges are at rest, we call it as electrostatic force on charge Q1 due to Q2. Okay, similarly your F21 will be your electrostatic force on charge Q2 due to Q1. Okay, now instead of this plus Q1 and here minus Q2, I'll have minus Q2. I will find there will be attraction among themselves. So this will be F12 here, F21 here. Okay. So what I observed from this, what observations I found? The first observation which I found from this was the force is acting on different body. Okay, the two forces. The second one, they are opposite forces, opposite in direction. Okay, opposite forces. And it was found the force magnitude are same. So these are the three findings what we observed from Coulomb's law. Okay, now comes that if these three things are being satisfied, then can we say that the electrostatic force forms an action reaction pair? Can we say that? Now the biggest question it is being asked, that this electrostatic force forms an action reaction pair and obeys Newton's third law. Okay, now we have to understand this. It might so happen that I will have a charge Q1, Q2, the forces here will be F12 and here it will be F21. Is such kind of situation possible? Is it possible? Probably the answer is no, it's not possible. Then do I need to modify this statement which I have made? Yes, this statement needs a slight modification. It needs a very slight modification. Now what is that modification? The modification is your electrostatic force forms an action reaction pair and it acts along the line joining the two charges. Okay, so you see this is not possible, but it has to be along the line joining the two charges, so it should be along this line. Okay, then only it will be possible. So this is one of the very important properties of your electrostatic force, and from this property another thing can be linked out, that your electrostatic force are central force, because it acts from the center of one of the charges to center of another charge. Okay, so we can say here that your electrostatic force are central force. Okay, so these are the first two observations which were found when Coulomb started to understand the force of attraction or repulsion between Q1 and Q2. Then he did some more experiments and tried to find out what is the magnitude, what would be the magnitude of Coulomb's force. So that we will be reading under scalar form of Coulomb's law. So we will read here the scalar form of Coulomb's law. So this electrostatic force which he was talking about, he found that the electrostatic force was proportional to the product of the charges q1 q2 and is inversely proportional to the square of the distance between them. When you remove this proportionality sign, a constant came k q1 q2 by r square, and this is the expression which you all are familiar with in class 10. And what is your k? K value is 1 by 4 pi epsilon naught, and this will be 9 into 10 to the power 9 Newton meter square per Coulomb square. Take up an assignment to find out the unit of k. You can easily find out because you know the unit of f r q1 q2, so you can find out easily. Okay, then question comes, what is this epsilon naught? Epsilon naught is nothing but it is permittivity of free space. Now permittivity means permittivity is of a medium. The way when you are inside a classroom, the teacher allows few of the students to read, the other section students are not allowed to go to that particular room, they go to some other section. Similarly, in a medium, how much electric field will enter into the medium, that permission is granted by this physical quantity, that is epsilon naught, or permittivity of free space. Now what is its value? Its value is going to be 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. And another interesting property is there that we'll read in detail when we'll read about capacitors, that is the value of k here, and this k is not the constant which I have written above, rather this k is your dielectric constant. This is your dielectric constant, which is also represented by epsilon r, or your relative permittivity, which is equal to epsilon by epsilon naught. So epsilon naught, you know it, and what is your epsilon r then? Epsilon r is your relative permittivity, okay, and your epsilon will be your permittivity of a medium. So this is what was found out, the expression for the electrostatic force from Coulomb's law. Okay, this you would easily know it. Now let's go actually what are the properties of electrostatic force. No doubt the first two observations what Coulomb got, that were the properties, but apart from that, is there any specific properties? Yes, so let's see what are the properties of electrostatic force. Now in this one, the first property will be your, it acts on minimum two charges. It acts minimum on two charges. Okay. The second one is your, the property which I have already written. It forms an action reaction pair. Action reaction pair along the line joining the two charges. Okay. The third property, it is a central force. It is a central force. The fourth one. Now, in order to understand the fourth one, I'll give you a small example. Suppose you have a charge q1, you have another charge minus q2, and you have another charge here minus q3. So if I consider charge q1, then there will be two types of forces falling on it. One along this direction, which will be F12, and other one along this direction, which will be F13. Okay, if I consider this one, then I'll have force F21 in this direction, right? So the point here is, if I am going to consider the charges Q1 and Q2, okay, then only two forces will act on it. Charge 3 will not affect the forces. So I can write here the force between two charges. The force between two charges is independent of presence or absence. So if I am going to consider the forces between Q1 and Q2, Q3 will be there, but it is not going to affect the forces. Okay, although the net force on Q1 will increase. Although the net force increases on Q1, but it will not affect the force between Q1 and Q2. Okay, presence or absence of other charges. So this is very important while we will be solving some problems. That will be very, very important for us. Okay, so these are the properties of electrostatic force. Now, did I talk something about your direction? I have not talked about the direction. Okay, so for that I have to go for Coulomb's law in vector form. I have to go for Coulomb's law in vector form, right? So let's see here. After properties, we'll go to your Coulomb's law in vector form, right? So for this, what we'll do, we'll take two charges, Q1, another charge Q2, which is situated at a distance r. Okay, now we'll see what all forces are going to fall on it. On Q1, the force will be in this direction, F12, and on Q2 it will be F21 in this direction. Okay, then this radius vector R12 cap will be along this direction, and R21 cap will be along this direction. So my F21 I can write as K Q1 Q2 by R square and R12 cap. And what is R12 cap? This is R12 vector. This I have already told in vector chapter in class 11, divided by R, and is a unit vector, in the direction from Q1 to Q2. So in any of the lectures, if you don't understand, you can repeat that, pause it, repeat it, and you can also take the notes. By pausing my video, you can also take the notes. And I am here giving my email ID. If you don't understand any particular thing, you can also mail me in the given email ID here. Okay. Now similarly, F12 vector will be K Q1 Q2 divided by R square, and is R21 cap. Okay, and we know that from the diagram itself it is quite clear that R12 cap is equals to minus R21 cap. So therefore what I can write here is F21 vector will be equal to minus F12 vector. So this is your Coulomb's law in vector form. So once we have read in such detail about Coulomb's law, then is there any limitations to Coulomb's law? Or it is flawless, it can be applied everywhere? No, there are certain limitations also. So let's highlight those points about limitations of Coulomb's law. Okay, limitations of Coulomb's law. So in this, the first limitation is the charges has to be at rest. The charges must be at rest. This is the first limitation. Okay. Second one, the charges must be point charge. They must be point charge. Okay. Next one, third one, the separation between the two charges. The separation between the two charges must be greater than the nuclear size. Greater than the nuclear size. Okay. So this is what is the Coulomb's law. So in today's class, what we have studied, I'll just brief it out. I have just given you a flow chart of all the chapters, how they are related. Then I have discussed about electric charges, and I have discussed about the properties of charges. Then we have gone to your Coulomb's law. We have studied Coulomb's law in scalar form, in vector form. We have understood the properties of electrostatic force. Then we'll finally end our class by knowing the limitations of Coulomb's law. So in my first lecture, these all things I have covered. I hope all of you must have liked it. Please press the bell icon below and like the video. This will give a motivation to give you the second lecture, where I will deal mostly with the problems which comes in the exam related to Coulomb's law. So I repeat again, any queries you have, you can just mail me in the mail ID which is being shown below. Thank you for your kind patience.